Okay, in this video, I'll go over what's called the extensive form of a game and how we use backward induction to find the solution when the game is set up that way. So we'll start with this example. Okay, Andy's parents give him two items and tell him to share one way or another with his brother Randy. So Andy has to offer a way of dividing the two items, and then Randy accepts or rejects the offer. If Andy accepts, then they divide the items as Andy has proposed. And if Randy rejects the offer, then they lose both items. Okay, so Andy's strategies are he proposes that he keeps both. So the split is 2-0. That's one strategy. Second, each of them gets one. So that's an even split, 1-1. Or Randy gets both. So the split is 0-2. And to each of these proposals that Andy makes, Randy can suggest yes or no. Randy has actually more than two strategies if we count it up in the technical sense, but this is fine for what we're doing. So you'll notice an important feature of this game is that they're not going to make a decision at the same time. So first, Andy's going to offer a way of dividing the two items. That happens first. And then Andy's going to accept or reject the offer. Okay, so to represent the game with this sequential feature, we'll do this. Okay, so Andy's three strategies will be represented by these three branches of this tree that we're going to create. And so he can either go 2-0, where he keeps both, do the 1-1 split, or he can do the 0-2 split where Randy gets both. Okay, then after Andy has acted, Randy gets to make a decision. Okay, so Randy's going to choose yes or no after Andy plays his strategy. All right, now we need payoffs, just like in any game. So we'll start with the 1-1 split. So if Andy proposes 1-1 and Randy says yes, we'll say that their payoffs are 1-1. The 1-1 split is between the two items, and this 1-1 payoff is utility numbers, but we'll just keep it simple like that. And then if Randy says no and they end up over here, then we'll make the payoffs 0-0. Okay, now if Andy proposes 2-0 and Randy says yes, let's say that the payoffs will be 2-1. So Andy's payoff is 2, Randy's is -1. Okay, Randy is player 2, so just like always, his payoff is the second value in the set. Okay, if Andy proposes 2-0 and Randy says no, then the payoffs will be 0 for Andy and 1 for Randy. So Randy's getting a little bit of satisfaction out of saying no in that case, I guess. All right, then if Andy proposes 0-2, both items go to Randy, then Randy's payoff is going to be 2, Andy's will be 0. And if in this situation Randy says no, then Andy's payoff, let's say, will be -1, and Randy's will be 0. Okay, so that's the game set up in this tree, or as we say, this is the extensive form of the game. All right, now to solve this game with backward induction, we will start down here at the bottom and look at what Randy is going to do in each of these three possible situations in which he might find himself. So if Randy has to make a choice from this point right there, from that choice node, then he can get either 1 or -1. He's going to choose no to get the to get 1. Now, if he ends up here after the 1-1 proposal by Andy, then he has a chance of getting Randy has a choice of getting 0 or 1. So he's going to choose yes to get the 1. And if Randy ends up over here after the 0-2 split by Andy, then Randy has a choice of 0 or 2. So he's going to choose yes to get the 2. Okay, so this outcome here is never going to happen. This outcome here is never going to happen. And this outcome is also never going to happen. All right, so Andy knows all of this. He can figure this out himself. So for Andy, the game is basically going to reduce to this. So if Andy plays 2-0, then the outcome is going to be, or the payoffs are going to be 0-1. If Andy plays 1-1, then the payoffs will be 1-1. And if Andy plays 0-2, then the payoffs will be 0-2. Okay, so for each of these, the payoff for Andy is the first value in the set. So he can end up with either 0, 1, or 0. He's going to want 1, so he's going to choose 1, 1. All right, so okay, so the solution to the game is Andy plays 1-1, and just got to remember what that goes with for player 2. That's going to be yes by Randy. So 1-1 and yes. And that's going to have the 1-1 payoffs. All right, here's the example from the reading. So in this case, we have two players. Again, the first player is Draco. The second player is Harry. And so in each case, they are casting spells. So Draco can first cast spell A or spell C. If he casts A, then Harry has the option of casting X or S. If Harry does X, then the game ends and they get that payoff right there, 5-5. If Harry plays or casts S, then Draco is going to play again, make another decision, and he can cast spell lowercase a or lowercase c. Those will lead to these outcomes. Okay, if Draco casts spell C, then Harry can do X prime or S prime. He can cast those spells. If he does X prime, then the game will end with this outcome, 4-5. If he does S prime, then Draco has to play again, and he can cast spell lowercase a or lowercase c, which will lead to those outcomes there. All right, now to solve this game with backward induction, we will start with these two choices that Draco has if Harry chooses S or S prime. So if Draco ends up here and he has to make a decision between A and C, his payoffs are the first value in each pair. So he's going to choose C to get the 3. If Draco ends up here, then his payoffs are going to be either 5 or 2. He's going to want the 5, so he'll choose A. Okay, so this outcome is not going to happen, and this outcome is not going to happen. So therefore, our game, in effect, reduces to this one. Actually, I can. Okay, so the value of each outcome for Harry is the second number in each set. So if he ends up here, then he can get either 5 or 4. He's going to want the 5, so he'll play X. If he ends up here, then he can end up with either 5 or 3. He's going to want the 5, so he'll play X prime. Okay, so that's not going to happen, and that outcome is not going to happen. So therefore, Draco's decision is essentially just this one. Okay, so Draco can end up with either 5 or 4. He's going to want the 5, so he'll play A to start the game. So the solution to this game is A, and the 5-5 is when Harry plays X, and that actually ends right there. Okay, there we go.